Are you a senior, Brian? You think so? Are you graduating in a couple of weeks? That's the question. I was gonna say if you're, oh, this must be an exciting time of year for you, man. Almost done with school. Congratulations. Let's get going today. Today we're going to do arithmetic sequences and series. Fairly simple stuff for most students. See, we have 2 assessments this week. Let's see here. So we're going to deal with arithmetic sequences and arithmetic series. An arithmetic sequence is a sequence that goes in order, like you add the same thing to it over and over and over again. For example, if I gave you 5, 7, 9, 11, 13, this is called an arithmetic sequence. And the reason it's an arithmetic sequence is because you're always adding 2 to get to the next thing. So when we talk about an arithmetic sequence, the d value is the distance between each number. So in this problem, the d value is 2. And then if we want to write an equation, so what you're going to be asked for this week is to write an arithmetic sequence for this. Okay, well, the only 2 things that you need in order to write an arithmetic sequence is you need the first term and you need the d value. Well, the first term in this problem that I gave you here is 5, and the d value is 2. So we just use this simple formula, a sub n is equal to a sub 1. And then usually I write it this way. I'll put the d out in front and then n minus 1. Okay, so all I have to do is I have to plug the a sub 1 in here and the 5 here. So a sub n is equal to 5 plus 2 times n minus 1. Now, I don't let students keep the parentheses here. So you have to multiply through here. So you'd end up with 5 plus 2n minus 2, or a sub n is equal to 2n plus 3. And I would always tell students to check your answer. It's really easy to check your answer because we have the sequence. The sequence is right up here. So if I wanted, this is the, oops, my marker's not working here. There it is. This is the third term here. So if I put 3 in to my explicit formula, so if I put 3 there, 2 times 3 is 6 plus 3, I end up with 9. So it does work. So to write an arithmetic sequence, super easy. All we have to do is have the first term and the d value. Okay? So that's an arithmetic sequence. That's how we find our nth term. Now, if we wanted to come up with the sum, okay, so let's take that same problem over. Let's say it was 5, 7, 9, 11, and 13. Okay, so I have 5 terms here, 1, 2, 3, 4, 5. And I wanted to find the sum of this one. Well, I could just add it up if I wanted to. I could just add 5 and 7, so that's 16, 21, 32, 45. So this would equal 45. So I could just add them all up. Well, there's a formula. Here's my formula. S of n is equal to the first term plus the last term in our list, divide by 2, times n. So in this problem, if I wanted to find the S of 5, that little 5 just means I'm finding the sum of the 5 terms. Okay, and that's what I have up here, 5 terms. Okay, so if I wanted to do that in this formula, this would be 5 times a sub 1, which was 5, plus the last term, which was 13, divide by 2. Oops, divide by 2. So 5 plus 13 is 18, divide by 2 is 9, so I'd end up with 5 times 9, which is 45. Oh, that's the exact same answer I came up with when I did it by hand. So that's a formula to find the sum of a number of terms. Like, for example, if I said find S of 100, oh, that would be, I would not want to write out 100 terms and add all those up. I would rather just use this formula and I could find the sum of the 100 terms much easier than having to add all those terms up. Okay, so those are the 2 major formulas for this week. Any questions on those? So the first formula is to find the nth term, And then the second formula is how to find the sum of the sequence. Okay, so if you're asked for the sum. So let's take a look at this week's practice. It says find the common difference, D, of the arithmetic sequence. So I've got 4, 6, 8, 10. So it's always going up by 2. So my D value here is just equal to 2. So my answer is just 2. That is the difference is the distance between each point. Problem number 2, it says find the common difference of the following arithmetic sequence, 3, 5, 7, 9. Well, looks like it's going up by 2 also. So I'm going to go with 2 again. All right. Number 3. Number 3, it says find the first 5 terms and determine if the sequence is arithmetic. Well, how do we find? Last week we talked about finding the terms of an arithmetic or of any sequence, and we just plug 1 in and 2. So if I plug 1 in here into this problem, if I plug 1 in here, 5 times 1 is 5 plus 3, that's 8. So my first term is 8. If I put 2 in there, I get 10 plus 3, which is 13. If I put 3 in here, I get 5 times 3 is 15 plus 3 is 18. Then if I put 4 in there, 5 times 4 is 20 plus 3 is 23. And then 28. And then it says, is an arithmetic sequence? Well, sure. It's always going up by 5. So 8, 13, 18, 23, 28. And yes, it is an arithmetic sequence. So 8, 13, 18, 22. Nope, that's not right. 8, 13, 18, 27. No, that's not right. 8, 13, 18, 23, 28. The sequence is arithmetic. So I'm going to go with letter D for this one. Find the 5th term of the arithmetic sequence. Okay, so the 5th term, I mean, they already gave us 4 terms here. They have 3 to 7, 7 to 11, 11 to 15. So it looks like the D value in this problem is just 4. So I'm always going up by 4. So 15 plus 4 is 19. Practice is pretty easy this week, hey? not too bad. I think you'll find the rest this week, next week, and the following week are pretty easy. All right, write the first 5 terms of the arithmetic sequence. Okay, so this time they don't give me a sequence. They give me the first term, but they also give me the distance between. So I don't even have to write out a formula for it. I know the first term is 3, and I know the distance is 6, so it always goes up by 6. So 3, 9, 15, 21, 27. I could keep going on and on and on. So let's see, 3, 9, 15, 21, 27. I'm going to go with letter C there. All right. Brian, any questions up until this point? As I said, it's a fairly easy week this week with arithmetic sequences and series. Okay. Find the 90th term of the arithmetic sequence. Okay, so now this one, I'm not going to write out 90 terms. There's no way. I'm not going to, keep adding, what is it? Oh, man, that's even a decimal that it's adding. So it's always, I'm not going to go up 90 terms. So what's my thought process here? Well, if I could come up with an nth term, I could just plug in 90 to find the 90th term. So what do I need in order to come up with the nth term? The first term, I need a sub 1, which I can see is 8.9. And I need the D value. Okay, well, the D value, if I just subtract any of the 2 terms next to each other, I get, so I'm just going to go 13.6 minus 8.9. And my D value is 4.7, which isn't a really nice D value, but it works. So remember, our equation is a sub n is equal to a sub 1 plus d n minus 1. So my first term, 8.9, plus d, which is 4.7, n minus 1. Now, I don't have to rewrite this because it's not asking me to write an equation. When I ask you, if I say what is the nth term, I would expect you to multiply through to get rid of these parentheses, but it's only asking us for the 90th term. So if I just plug 90 in here, I should get my value. Now, if I put 90 in there, I end up with 8.9 0.9 plus 4.7, and then 90 minus 1, which is 89. Now I get my calculator out. Okay, so 4.7 times 89, and then plus 8.9 plus 8.9 is equal to 427.2. So 427.2. So that would be my 90th term if I had to write them all out. And I'm not going to write them all out, but the 90th term should be 427.2. Okay, so that was a little bit tougher. It made us think about, how do I find the 90th term without having to write them all down? Well, if I can come up with an explicit formula, then I can find the 90th term just by plugging it in. All right. It says find the formula for a sub n for the arithmetic sequence. Okay, so it gives us the first term, it gives us a d value. Okay, so now, again, the formula for this week, a sub n is equal to a sub 1 plus d n minus 1. Well, they gave us the first term, they gave us the d value. So a sub n is equal to -2 plus -6 n minus 1. Well, this is the only one that has a parenthesis in here, and it's not right, so I'm going to multiply through here. So that gives me -2 plus -6n plus 6, because -6 times -1 is +6. So my equation is going to be -6n plus 4, because I just added the -2 and the 6 together. So a sub n is equal to this, -6n plus 4, which is the exact same thing as this right here. Doesn't matter if we put the -6n in front or back behind. Okay. Determine whether the sequence is arithmetic. If so, find the common difference. All right, so in this problem, Brian, is this an arithmetic sequence? And if so, what is the common difference? Yes, it is an arithmetic sequence. Then what is the common difference? Okay, because remember, you have to add that number each time. So when I look at this problem, if I go from 5 to 25, I'm adding 20. If I go from 25 to 125, I'm adding 100. If I go from 125 to 625, I'm adding 625. This is really a geometric sequence where you're multiplying by the same term. And that's what we're going to deal with next week. So this is going to be next week's assessment, being able to, so the R value, it's not a D value anymore, it's an R value, and that R value is really the ratio. What do you multiply each term to get to the next term? So this is not an arithmetic sequence because it's not always adding the same thing to get to the next one. However, it is a geometric sequence, and that is what we'll be dealing with next week. But we don't have to deal with that right now. It's not arithmetic sequence, so we don't have to do anything. Find the formula for a sub n for the arithmetic sequence. Now this is a tough problem, okay? And the reason it's tough is because we do not have the two things that we need in order to come up with an arithmetic sequence. What do we need? We need two things. We need the first term, and we also need the, so we need a sub 1 and we need d. We don't have either of those in this problem. We have the fourth term and we have the seventh term. Okay, so 1, 2, 3, 4, 5, 6, 7. We have the fourth term, so we know this term is -23. We also have the seventh term, 5, 6, 7. It's -44. So this is the fourth term. This is the seventh term. So how do we get the d value? It's fairly easy. All we have to do is subtract the top numbers, okay? Because how far apart are they? They're 3 apart, okay? 4, 5, 6, 7, so they're 3 apart. And what is the number distance between there? So I've got -23 minus -44, so they're 21 apart. So this will give me my d value. So my d value is -7 because it's always going down. So let's check and see if it works. So if my fourth term is -23, my fifth term, if I go down by -7, would be -30. Then my next term would be -37. Then my next term would be, oh, it does work. So how am I going to get this way? Well, I'm going to do the same thing because I need a sub 1, right? I need the first term. So I'm just going to take -23 plus 7. So that would be the third term, would be -16. The second term, if I subtracted 7 again, I would get -9. And then if I subtracted 7 again, I'd get -2. So now, lo and behold, I have the first term, which is -2, and I have my d value, which is -7. So I can use the formula a sub n is equal to a sub 1 plus d n minus 1. So a sub 1 is -2, d is -7, n minus 1. So that gives me -7n plus 7. So -7n plus 5 would be my a sub n. -7n plus 5. So I'm going to go with letter C here. All right, Brian, does that make sense? I mean, that was a lot. I mean, I had to do a lot of stuff there. First I had to find my d value, and then I had to go backwards to find my first term, and then I had to plug it into my equation. It was a lot in one problem. Is that okay? All right. That was the last problem on the practice for the week. That is it for this week. Any questions, Brian? All right. Have a great week. Hopefully, I know by Friday it's supposed to start getting nicer out. So hopefully we get some nice weather soon. Have a good one. Bye.